Hey guys, today we are going to do Chapter 9 review. A lot of you sent me your review problems and you did a great job. A few of you had some questions and I thought that it would be a good idea if we just went over all of them together today. And please, as you're watching this, if you see anything that you don't understand or you want another look at or just want to ask me about or ask clarification on, just let me know. Send me a message and just say like, hey, Miss CC, I wasn't sure about what you did there, or, you know, can you do this one again? And I'd be happy to help anybody look at any of this again. So let's just start out at the beginning. It tells you that you have you're trying to make a concrete column. And I don't know if you know, but most of the time, I guess they don't always have to be shaped like cylinders, but in this case, they're assuming that we know that they mean that the column is a cylinder. And so all we need to do is take the information that they're giving us, and we're gonna take the formula for volume of a cylinder, and we're gonna plug in the numbers. So hopefully at this point, you guys have already put together your formula sheet with all the different formulas for the geometric shapes we've learned in this unit. So hopefully it's not hard for you to just take a look at your sheet or your notes and find where you have volume of a cylinder, okay? So volume of a cylinder, okay, like we learned last time, or actually a while ago, but we reviewed last time, it's pi r squared times the height. So we're gonna remember this a lot, where we have to have a lot of shapes that have the area of the base times the height. Okay, anything that has like a matching top and bottom, which we'll look at another shape soon on the review sheet where you had to apply this. So just like this, we have this column, right? So we're telling you that it's, let's see, they say that it has a radius of 10 centimeters. Okay, and then the height is 300 centimeters. It's a column. It's a really tall thing at your house, or at their house. Okay, so I have 10 centimeters for the radius of the circle and 300 centimeters for the height of the whole figure. Okay, so we're just going to take our formula. Okay, and then we're going to plug in pi, times 10 squared times the height, which is 300. So for these, I'm going to be just using 3.14 as my approximation for pi. I just punched it in the calculator, and you guys can do the same, or if you want to, you can use the pi button on your calculator, but remember that your answers may be slightly different than mine, just by a few numbers or just decimal places, and don't worry if that's the case. So again, so then that ends up with 3.14 times 100, because it's 10 squared, times 300, okay? So again, remember that anytime you're using pi, your answer is approximate. So we have approximately 94,200 centimeters cubed, right? Why is it cubed? Because we're doing the volume, the cubic centimeters that can fit in this whole column, right? So the answer I got was 94,200 centimeters cubed. And if you use the pi button on your calculator, you would get something more like 94,247.78 centimeters cubed. But remember, both answers are fine. And when you're taking the quiz, just find the answer that's the closest thing to what you got. And I mean, as long as it's really similar with maybe just a couple things off and the decimals are in the ones or tens place maybe sometimes, then your answer is fine. Okay, so that was number one. Let's move on to number two. Remember, when you're watching this, if you have any questions, just write to me and say, oh, I need to see that again, or in case I do anything weird or I accidentally label my units wrong or something, just write me and double check and be like, Miss CC, can you look at that one again? Okay, so the next problem is about a triangular prism, okay? Just like the kind of prism you see, for example, on the Pink Floyd album cover, or you see it in science whenever we talk about separating the different wavelengths of light into different colors, the spectrum of colors. So on the review sheet, it kind of looks like this, where they have it up and down, right? But you might have seen it kind of at some point in your life, like this long thing that's a triangle, and there's light going in, and then all the light is coming out in different rainbow of colors. So that's a prism. It's a triangular prism, technically. You might see it called just a prism a lot. 1 second, I just want to make sure this is working well. Okay. So in the problem, they have this tall prism that looks like this. Okay, and they're kind of trying to lead you into figuring out how to solve this by yourself without a formula. So it's like, how would you find the volume of this shape? Okay, it's a triangular prism, so we have two matching triangles on the top and bottom, and then the tall, long height of the figure. Okay, so remember how we did a cylinder and we did a rectangular prism where we used the formula of just this simple formula for any shape that's like this, where you do the area of the base multiplied by the height, okay? By the height of the whole 3D figure. So this is a really similar shape to those ones. Both the top and the bottom are identical triangles, and basically we're gonna find the area of the base of the triangle and multiply that by the height. Remember how I kind of compared it to Play-Doh when you're a kid and you have a shape and you squeeze the dough through it, and I said the word extruding, so this is like something you might see later, but you have the shape, and as you squeeze something through it, you're just taking that base and you're just like like multiplying it times however long the height is, okay? So that's what we're going to do here. So for that, remember, first of all, if we want to find the area of the base, what kind of shape is this? It's a triangle, right? And so how do you find the area of a triangle? 1/2, right? So area of a triangle equals 1/2 base times height. Okay, so right now we're just going to do this part, and then we'll multiply it by the big height. Technically, you could just do it all in one, like 1/2 base times height, and then times the big height. But let's do it in 2 pieces for now, so we can be really clear. Okay, so if we take our triangle, and we have, let's see, they tell you that the base of this triangle is 7 inches, and the height of it, they say, is 5 inches. Okay, so we're gonna have 1/2 times 7 times 5. Okay, guys? So 1/2 times 7 times 5 comes out to 17.5 inches squared, because right now we're just doing the area of this piece. And now we're gonna add the third dimension, right? We need to know this piece, basically multiply this whole height, this whole direction, to get the whole inside of area. Now it doesn't look like the right shape anymore. But yeah, so we've got our triangle. We want to multiply it by this height that we want to find. Okay, so the height of the entire 3D figure is 12 inches. So then I'm just going to take the 17.5 times 12, okay? And 17.5 times 12 is 210, and then it's inches. Now it's cubed, guys, because we have 3 dimensions, volume. So 210 inches cubed. So as I'm going through these, hopefully you guys have out your review where you already did the problems, and you can check your answers and let me know if you got the same thing I did, and I'm gonna check over the ones you guys sent me. Don't worry if you got any wrong, it's totally fine. Just go ahead and watch this and take notes of any mistakes you may have made and see if you can get the right answer. A lot of you, it looked great. I think that a few of you just had a few questions, and but yeah, so follow along and just be checking whether you got these answers or not. And if you want to ask me why yours is different, just go ahead again, just shoot me a message and we can talk about it. Okay, so that was number 2. Let's do number 3 now. Okay, so number 3 is talking about the volume of a cone. Okay, so in this one, they just basically, they already drew this cone, and they tell you the dimensions of it, okay? So they say, find the volume of a cone. So you guys should be able to look at your formula sheet, find the volume of a cone, and the volume of a cone was 1/3 times pi r squared times the height. Think about how pi r squared times the height is like the volume of a cylinder, and so a cone is like a third of that. So we're just going to take the information they gave us. We have 1/3 times pi times, they have the radius is 8, so 8 squared times the height. The height is 21, okay? I'm just getting this from the figure that they give you. It says 8 feet, and then it says 21 feet, okay? Probably can't read my writing on here. But yeah, so you can follow along on that PDF that I sent you on Monday if you want to look at the worksheet while we're doing this. So we take 1/3, oops, I'm not watching. Sorry. 1/3 times pi times 8 squared times 21. Okay, and remember that 8 times 8 is 64. So you can plug that in there. I just kind of multiplied this and then divided it by 3. You can also put it in as a fraction 1/3 times this. There's a lot of different ways that you can arrive at this. But so if you multiply all of that out, you're going to get 1,406.72. So remember, this is approximate because of pi. 0.72 feet cubed, because we're doing the volume, okay? So 1,406 or 1,406.72 feet cubed. Yay. Number 4. Okay, so number 4 is showing you a cylinder, and now they want you to find the surface area. So be cautious when you're taking the quiz or when you're reading homework problems or whatever, just to make sure that you're looking at what they're asking you for. Are they asking you for the volume or for the surface area, or something else? So remember that with a cylinder, when we do the surface area, it's the one where we talked about cutting apart the can. So you end up with a circle, and a rectangle, because you cut this and you unfold it, and you get, it's like if you took a can of soup and you pulled the label off, the label is going to be a rectangle because it was fit around that cylinder, okay? So again here, that's why our formula for surface area of a cylinder, right? It's 2 parts. We have to add together 2 of these plus 1 of these. Do you guys remember that? So we've done that a few times. So it's 2 times pi r squared, okay, because the pi r squared are these parts, and there's 2 of them, all right, plus 2 pi r, which would be the circumference here, times the height, okay? So 2 pi r squared plus 2 pi r times the height, 2 pi r h, okay? Again, I hope you have all these organized so that it'll be really easy and clear whenever you need them on your quiz. So we're going to plug in the numbers here. So interestingly, they give you the radius is 5 here, 5 feet, and the height is also 5 feet. So it's interesting, actually, not always, this won't always be the case, but in this case, this number and this number are going to be the same, and I'll show you why. We have 2 times pi times a radius, which is 5 feet squared, right? Plus 2 times pi times the radius, which is 5, times 5, which is the height. So do you guys notice we have 5 times 5 here, and 5 times 5 is here too. And that's just because this time it was the radius squared, and this time it was the radius times the height, and they both happen to be 5. So if you do those, you're going to end up with 157 plus, again, same thing, 157, all right? So if you add those together, you get 314 feet squared. Why is it squared? 314 feet squared. Is it feet or inches? Oh, I'm sorry, it's inches. So this is the kind of thing you can be like, CC used the wrong measurement here. So it was supposed to be inches. 314 inches, still squared. Why squared? Because it's surface area. We're just doing the area, like the flat space around the outside of this figure, not the inside. So it's squared, all right? Did you guys get 314 inches squared? I hope so. So if not, no big deal. Just take a look and see what you might have gotten confused on. So next is number 5. And this is about a surface area again. And actually, I gave you guys a little heads up on this. A lot of times I like to have students just kind of take this as a challenge and see if they can figure it out on their own. And I think you guys could have done it for sure. Since we're not together and we can't try this in person, I want to make sure I give you all the skills that you need to solve this, okay? So for this one, they say, this is a square pyramid, right? And they kind of walk you through it. I mean, I wrote this, so I'm trying to walk you through this. Meaning the base is a square and all of the triangular sides are equal, okay? And they meet at a vertex at the top. And we talked a little bit about this last time. So we have this pyramid. It's kind of hard to draw for me, but that one's okay. So we have this pyramid and you can like imagine the back of it. So the base is a square and the sides are all triangles that are equal to each other. And so just like with taking apart the cylinder, like a soup can, you know, you can do something similar with this. Imagine you're cutting apart this pyramid and taking the pieces and adding them together to get the surface area, okay? So basically, to find the surface area of this, let's just break it down with words, okay? We want the area of the triangular sides, right? So of the triangle side, how many of those are there, right? 4. So we're going to say times 4, okay, plus the area of the square base. Okay, so it's going to be like a triangle, 4 triangles in fact, plus a square. Let me know if this doesn't make sense to any of us, okay? So with that in mind, I'm going to take the area of a triangle, 1/2. Remember the area of a triangle is 1/2 base times height, okay? Let's just start out and keep it simple like that. So what is the area of one of these triangles? They tell you that, remember we talked about slant height, and this is this weird thing, okay? Because if you were doing the volume of this, which we are not, we would need the inside height of the, like from the ground up to the vertex. We don't want that in this case. We just want the outside. And the outside height is going to be different because it's this triangle leaned on its side. So we want the slant height, which they tell you is 12 here, 12 centimeters. Okay, so we have a 12 centimeter slant height. All right, and they tell you that the base, which is a square, is 7 centimeters. Okay, so we have a 7 centimeter base of this triangle, and we have a 12 centimeter height. So we're just going to go 1/2 base, which is 7 times height, which is 12. Okay, so you guys can probably do that quickly. That is 42. Okay, so that means that one triangle is 42. Remember that we need 4 of them. So I'm going to do 42 times 4, all right? And 42 times 4 is 168. All right, and remember that this is centimeters. In this case, squared because it's area. I'm going to erase some of this so that I can finish this on the same screen. So the triangle parts alone, those are 168 centimeters squared. Like this one is 42 plus 42 plus 42 plus 42. Does that make sense? So that altogether is 168 centimeters squared, but we're missing the bottom. And this happens to some students on the quiz too. They do this part and they forget that there's a bottom. So what if we need to paint the bottom? We need to know the area of this square. So the square is 7 centimeters on this side. So that means if it's a square, it's also 7 centimeters here. So 7 centimeters times 7 centimeters is what? What's 7 times 7? 49, right? So then we're just going to add 168 plus 49. So 168 plus 49 is 217 centimeters squared. So that's what I got for that one. Okay, does that make sense, you guys? We just took the area of each triangle and the area of the square base, and we added them all together. So, moving right along to number 6. number 6 is asking you a question. It has this angle, which I think you guys understand this. So it has this angle that looks kind of like this, right? It has like M, N, P. And it just says, what type of angle is this? Do you guys remember? What kind of angle is it when it's like wide like this? All right? Who remembers? It's called obtuse, right? So this is an obtuse angle. And it says, using that answer, do you think that the angle measure, this here, is less than 90 degrees, equal to 90 degrees, or greater than 90 degrees? I hope each of you can do this. Is this an obtuse angle less than, equal to, or greater than 90 degrees, guys? It's greater than, right? Because remember, 90 degrees is like a box. And if it's opened up wider than that, it's going to be more than 90 degrees. Does that make sense? Hopefully all of you got that one. Okay, so then moving right along to number 7, sometimes it'll say something like this. Find the area of this figure. And then they'll just have an easy thing, so don't let that confuse you. It's just a triangle. Okay, but they actually give you 3 measurements here. They have 6 meters, 18 meters, and 19 meters. Look at this. This is the hypotenuse, okay? It says find the area. Do you guys think that we need the hypotenuse to find the area of a triangle? Do we need the length of this piece? So be careful, because they might try to kind of just make sure you know what you're doing, and they'll give you extra information, okay? But no, we don't need this part at all to know the area. Maybe if you wanted the perimeter, we don't need the hypotenuse when we're looking for the area of a triangle. We just need the height, which we have here, and the base, okay? So forget about the hypotenuse. You know that your area of a triangle formula is 1/2 base times height, right? And so we just need to plug in 1/2 times 18 times 6. Okay? So 1/2 times 18 times 6 is 54 meters squared, because we're doing area. I hope you guys are getting really comfortable with what type of units you're doing. Are you doing squared, just straight up linear, no squared or cubed, just the unit, or cubed, of course, is volume. All right? That one was not too hard. I think the trickiest part was the extra information they gave you, so we did not need that hypotenuse. Okay. So number 8 says, find the circumference of a circle with a diameter of 12 inches. Now, this is a few things. For one, they just say circumference. They don't show you a picture or anything. If you want, you can draw one. Remember that circumference is just the distance around the outside. And hopefully, you know what? Did we put circumference on our formula sheet? I don't remember. Okay, guys, so just in case we didn't, remember that a circle, we solve for circumference, which is 2 pi r. And then, so this is circumference of a circle, and area of a circle, you guys, which we're not doing in this problem, but is pi r squared. So maybe make sure you add that back on your formula sheet. I think you have it by memory by now, these two, but just in case, I can't remember if we put this on. So squeeze it in there somewhere, or just add it to your notes, and you're welcome to look at that when you take the quiz. So circumference of a circle is 2 pi r, and the area of a circle is pi r squared. All right? I'm going to take this part off just because right now we just want to look at circumference. So in this one, they kind of give you some options in a way. They say that you need to find the circumference of a circle with a diameter of 12 inches. Now, read carefully. Diameter is 12 inches. The diameter. All right, what do we usually use? What is this asking for here? Radius, right? Okay, but you actually have 2 options here. If you want to just straight up use this formula, which, you know, I kind of recommend, what do you need to do to find the radius if they give you the diameter? You need to cut it in half, right? So that means that our radius would be 6 inches. Everybody agree with that? So we can do 2 pi times 6. And that gives us 37.68 inches. Okay guys, so one thing I want to say real quick is there is no inches squared on this one. It's the circumference. Circumference is just a linear measurement around. So we're not squaring anything, it's just inches. It's like you measured around the outside, straight. Okay, now another choice you have if you're thinking and you don't want to let it confuse you, but remember that another way to look at circumference, because we have this 2 and this r, okay, another way to think of circumference is pi times d, or d times pi, right? Diameter times pi. Now, they gave you the diameter. If you wanted to, you could just do your 3.14 times 12, and you'll get the same thing. Because here you had 2 and 6, which is 12. So you also get 37.68 inches, okay? But you guys decide. Don't let it confuse you. Just remember, if you need the radius, then you need to divide the diameter in half. Sometimes you need the radius, you do need the radius for area, so don't, make sure not to use diameter if you're using the area formula for anything. Alrighty? Okay, I'm just gonna double check that we're filming here. Yep. Okay, so we are almost done. We just have to do a few more problems here. Okay, so the second page, it starts out with classify these triangles, okay? And so they show you different triangles. There's one that looks kind of like this. There's one that looks like this, and it has these measurements like that, or these notations. There's one that's kind of random. Okay, then there's one that's like this. What does it say? Which is, okay, it could do this, but it has an A, so meaning that all 3 of those sides are the same. And then there's one that looks like this. Okay, it says classify these as either acute triangle, obtuse triangle, right triangle, isosceles triangle, or equilateral triangle. Do you guys remember these? Okay, so which one is acute? It's kind of tricky actually, because a couple of these could be acute depending on the measurements that they have, but the other ones also have other fancy names. So let's just go with this random one here, because it tells you that the angles are 80, 54, and 46. Okay, so remember that a triangle that is an acute triangle, it's going to have actually all 3 angles are less than 90 degrees, right? So acute has 3 angles less than 90 degrees. Okay, so this one is acute. So the third one they show you. Okay, then the next one says, which one is obtuse? You guys know, this one is obtuse. Okay, obtuse means that there is an angle that is bigger than 90 degrees. Guys, can there be more than one angle that's larger than 90 degrees? Can you have a triangle with 2 obtuse angles? Think about it. No, you can't. You cannot have more than one obtuse angle. Think about how you'd have you wouldn't be able to close back to be a triangle. Okay, so which one is a right triangle? Everybody should know that, the 90-degree one. This one's a right triangle. Okay. And then it asks you for isosceles and equilateral. So remember that isosceles has 2 equal sides and one that's not equal, right? It's like it's this symmetrical thing you could fold in half, but 2 of the sides are equal and one is not. So sometimes it might be obtuse, where 2 are equal and one is not. So that could also be an isosceles. And like I was saying earlier, this could also be acute, but this is the specific one that they're showing you acute. And then the last one is equilateral. That means equal sides, so all 3 sides are equal. This one is the equilateral. Okay, let me know if you guys had any questions on those. That's just kind of a review of things you might have learned before. All right, that was number 9. Number 10, I actually had a lot of questions from you guys about. You might remember we did these similar triangles. It says that triangle ABC is similar to triangle EDC, okay? And the way they have it drawn is like this, and actually it's talking about it as a map. Okay, so they have like these cities like Maryville and Joinville. Okay, so they're saying that it's like a map, right? Some of you may have become confused because when we looked at these examples of similar triangles before, we didn't have them turned like this. So if it helps you, you could think about taking this triangle here and actually turning it around upright so that it's kind of looking more like what we learned. Sorry, this looks terrible. Two similar triangles like this and this one. Okay, guys? So that might help you to keep it straight, or, you know, maybe you can see it like this as well. But so it's in kilometers. They're showing you a map. So they have different measurements here. So we have A, B, C, and then D, E. Okay, so if you want to do it on this one, let's say A, B, C, and then this one is, if you turn it over, if this helps you, I don't know, E, D, C. Okay. So they're missing this. This is an X, and it wants to know the distance between Maryville and Joinville, which is this A to B here. They want to know A, B, or what they've labeled as X. Okay, and they give you some measurements. They give you, here is 16 kilometers, here it's 18 kilometers, and here's 12. And we don't have any other information. Luckily though, that's all we need. Okay, so I'm gonna relabel these X, 12. So remember, if we flip this around, it's gonna be 18. Gosh, I keep doing this. Okay, 18 and 16 here. All right, and so what we need to do, if you remember, is set up a ratio. You need to look at the parts that are equal, and there are a few ways to do this, but, or actually, you know, equal is not the right word to use, but similar, okay, that's the right word. So I'm gonna just do it like this. X over 12 equals, because it's a ratio, so dividing X over 12 should give you the same number as dividing the coordinating pieces of this bigger triangle. So which coordinates with X? This 18. So equals 18 over, and the 12 coordinates with the 16. Now, some of you could have done it differently. You could have done X over 18 should equal 12 over 16. That would be okay too. You'll get the same type of formula, but let's just do it like this. So I'm gonna cross multiply. Do you remember when we looked at why this works? You would be doing the same thing if you solved it kind of in more slow steps, but this is perfectly fine and it's going to get us the same answer. So we get 16x equals, so 12 times 18 is 216. So we're going to divide by 16. All right, so 216 divided by 16 is 13.5 kilometers. So the answer for that one is 13.5 kilometers. So it's just looking at these two triangles, doing a ratio, and solving for the missing piece. It did look more difficult because they have it in this weird configuration, but don't let that confuse you, okay? You just make a ratio. Let me know if there's any questions on that one, please. All right, so next we have a couple more problems, I think 2 more. We have number 11, which is talking about a donut sign. So let's say you own a donut shop and you want to make a big wooden sign for your shop, okay? So you have this donut sign, right? Okay, something like that. So they give you the information that the sign, the center, which you're going to cut out, has a radius of 2 feet. So let's say this is 2 feet, okay? And then it says here, the rest of the donut extends 4 feet beyond the edge of the middle circle. What is the area of the wooden sign, not including the center? Right, so the radius of the middle is 2 feet. We're gonna cut that one out. This is like those irregular shapes we had before. And then it says like, from the edge of that circle out to this is 4 feet. Okay, so imagine this whole section around here is 4 feet. So that means that this here is 4 feet. So we have 2 feet, and then we have 4 feet. Okay, everybody understand? So what is the radius of the big circle? All right, big circle radius. Okay, what would it be if the whole circle starting from the center is 2 feet and then 4 feet? So that means it would be 6 feet. I thought this marker was better. It's just like being at school, guys. Miss Cece can never have a marker that works. Okay, so the big circle radius is 6 feet, and the small circle's radius is 2 feet, like they gave us. So to find this, what we want to do is take the big whole circle and subtract the small circle, because we just want the donut shape without the middle. All right, so we find the area of the big circle and subtract the area of the hole in the middle. So remember that the area of a circle is pi r squared. Okay, so we're going to take the big one. So the big one is going to be pi times 36, right? So that's approximately 113.04. And then the small one is going to be pi times 4, because 2 times 2, 2 squared. That's going to be 12.56 feet squared. This one is also feet squared. All right, so we're going to take 113.04, which is like, it would be this whole circle, if you had this whole circle, right? Minus the inside, because we only want this ring shape. So 113.04 minus 12.56 is 100.48 feet squared. Okay? So that would be the area of your donut sign. Okay guys, so finally we're on number 12. Number 12 is kind of weird. It's talking about a square picture, like you have hanging up on your wall or something. So let's draw it. So there's our square picture. Okay, they say that inside, it says a 15-inch square picture has a 3-inch wide border around it in its frame. So this is like a picture on the inside. Square picture. Okay, so this is 15 inches, and this is 15 inches here to here. Okay, guys? That's what they're trying to say. So a 15-inch square has a frame around it. It's 3 inches wide, like the border is 3 inches wide, okay? They want to know the total area of the whole thing. So that means this whole entire shape, like how much area is it going to cover on your wall, including the frame, including everything. This is trickier than it looks. I'm curious how many people got this right. So the 15 is, this is 15 squared in here, but then we have to add on the area of the whole, like the frame. So they say that this is 3 inches, okay? But that means that this is 3 inches all the way around. I'm gonna actually draw it bigger. So 15 inches here to here. Okay, but then this is 3 inches, and this is 3 inches. So that means that this bottom, like the whole entire edge, so we have 3 inches, 15 inches, and 3 inches. Does that make sense, you guys? 3 inches. So all around is 3 inches, extending past the 15. So that means that this entire side is going to be 21 inches. Can y'all see why? So we have 15 inches here, and then we have 3 and 3. So 15 plus 16, 17, 18, 19, 20, 21. Okay? So if we have 15, my power just went out. That's okay. So yeah, and this is getting long, but I think you guys understand. Let me just draw it one more time. Sorry, I got distracted whenever the power went out, but my video should keep going, so. All right, so all of this to say that we have 15 inches, 3 inches, and 3 inches. This is probably more clear. So the entire side is 21 inches, and it's a square. So this is also 21 inches. Okay, guys? So 21 times 21 is all we have to do here. 21 squared. All right? So 21 squared is 441 inches squared. All right, so the answer to this one is 441 inches squared, because all you did was you took 21 times 21 and to find the whole area of the whole shape, and it was 441 inches squared. And the question is more difficult than actually solving this problem, as you notice. So if you see something like that on your quiz, just read carefully and see what they're asking you for. All right, guys, well, that's all the problems on the review sheet. I hope that this helps you. Please write me if you have any questions, and we are going to chat and see. I know that you guys have a lot of quizzes in your other classes going on recently, and I don't want to stress you or put too much on your plate. And so let's chat for today's assignment, I guess. I want you to let me know what other quizzes you have next week and what time slots you are busy. Like maybe when is your English class? When do you have other quizzes? And hopefully you have a way that you're keeping organized and keeping all of this written down for yourself, so you can, you know, keep your schedule clear and not get confused. But let's work together to figure out when and how you guys would feel most comfortable taking our math quiz. And it doesn't have to be, you know, Monday. We can be really flexible. Just maybe send me a message. Let me know how you did on this review, if you have any other questions, and then when you might have free time to take the quiz, and we'll talk about how we're going to do that. Hope you have a great day, and I'll talk to you soon. Bye.